Assalamu alaikum. Inshallah, today we will speak about relational model. Sorry. Okay, today we will speak about relational model. We are a little bit late, so maybe we will take 2 chapters today if we have time, inshallah. Okay, in this chapter, we will speak about relational model and relational database constraint. Okay, shortly in this chapter, we have some terms and some constraints on relational model. We will speak about it. Then, after finish this chapter, chapter 5, we will go directly to chapter 9 to see how to make mapping from ER diagram to relational model or to relational schema. Okay, so it's a small change in our syllabus. Maybe if some of you look to our syllabus, the organization was relational model, then relational algebra, relational calculus, then mapping. No, I will bring the mapping before the relational algebra and relational calculus, because after we speak about the concept and constraints in the relational model, we need to see how to apply this during the mapping. Then after that, we will speak about relational algebra and relational calculus. Okay, as you can hear, we speak about some mathematics, relational algebra, relational calculus. Why? Because relational model in the database, its concepts or the major concepts here, it's about relation, and it's depend on or it's founded to use the theory of relations and the part from mathematics that depend on the sets. Okay, so relational model of the database concepts use the relation and we use this model because we can depend on the theories of relations from mathematics. So in this chapter, we will speak informally about some concepts. Then we will see how to describe this model using formal methods. Okay, then relation. What is the relation? I know many of you have the idea about database. Okay, database, I have tables, and these tables have columns and have rows. Here in relational model, we speak about, sorry. Could you please turn off your mic, except if you have a question? Ahmad, turn off your mic. Okay. Then relation, it's the table actually in the database. You can informally consider it as a table inside the database. And this table have columns. We call the header of the column, we name it attributes. And the rows, we name it tuples. Okay. Then we have relation name, which is the table name. And we have the column names here. We use the term, attributes. And for the rows, we use the term tuples. Then relational model or relation schema will have many relation and shows a relation and constraints in this relation. The term relation use mathematical concepts based on set, the idea of set. And we know sets, we can make union between sets, we can make we will see many mathematical operation about sets applied here. That's why we see the relation as a set of tuples, and each tuple it's like a set. Okay, Ahmed, what do you want to show us? Ahmed, it's second time you disturb us here. You have anything or it's...
I am sorry, doctor. I am sorry, doctor.
Okay.
No.
Okay. Then, if we look informally to some the meaning of informally and formally. Formally, we will use some terms from data set and relation theory from mathematic description for this relation and its component. Informally, just to make you connect this to the idea of tables inside the database and column and row. So informally, relation is similar like tables. And this relation usually have a set of rows. Rows here we called it tuples. In the relational model, we don't use the term rows. We use the term tuples. Okay. Then rows is the tuples or the rows that have information inside this relation. Okay. I will not everything inside the slides I will mention because it's not really difficult to read it. Okay. So inside columns or inside this relation, we have columns. The column header, we name it attribute or attribute name. So as we mentioned, we have the relation, here's the relation name. We look to it as a table, okay? And we have the tuples, and we have the column name, we called it attributes, okay? Keys of the relation. As we mentioned last time also when we speak about when we spoke about ER diagram, that we choose item or set of items that uniquely identifies a row in the table. This item or set of items may be more than one item, cannot be one item. Sometimes can be one item can uniquely identify this row. Sometimes we need more than one item to uniquely identify a row. This item or set of items that uniquely identify the row, we called it key. For example, in this student table, we have SSN, Social Security number, or here Kimlik number, we called it Kimlik in Turkey. So because it's unique and cannot be repeated for any row, we take it as a key. Sometimes we make row ID or sequence number and use it as a key. Usually we name it artificial key or surrogate key. For example, in the university, we usually give for the student number. Okay. For employees, sometimes we give sigil number here in Turkey or employee number. Okay, this number that we give, it's artificial key, not come from the real world. Okay. However, sometimes you really have ID or passport number, you can use it, but we find a new key. Sometimes, not always, sometimes, like we give sequential or serial number for something, we can use it as a key also. Okay, for the formal definition, for the schema or relational schema, we usually use for relation this definition. For relation, okay, we use this definition R A1 A2 until AN. R here the relation name. For example, if we speak about the student, then we will name it student. Then we mention the attributes name. Okay, then A1, A2, it's the attributes name. For example, here for customer, we use customer ID, customer name, address. If you look to this definition, it's the definition for the relation. Okay, then to define the relation, we give relation name, and between brackets, we put the attributes name. Each attribute has a domain or set of the valid values. For example, customer ID here, we have to mention what is the domain for it. For example, customer ID 6-digit numbers. Okay. What about tuple? Here, this formal definition for the relation. Okay. For the tuples, we use this angle practice. What is the tuple? Tuple is an order set of values. What is the values here? The values come from the domain of the attribute. Okay. Then, what is the definition for the tuples? Tuples is the order set of values. I mean by values here, all the values that come, any values that come from the domain of the attribute. Then each value derived from the domain of the attribute, each value in the tuples. Here is an example for tuple or set of values come from the customer relation. For example, here we have the customer ID, customer name, customer name and address and phone number. How many attributes we have here? 4. Then this 4 tuple. This means this tuple have 4 values. Okay, then we defined here the relation formally like this. We define the tuple formally like this because tuples a set of value. What about the relation? Here relation a set of tuples. A set of tuples. Okay, this is important. It's a set of tuples. That's why we can, after converting our ER diagram to relational model and use this relational model as a set of tuples, then we can use all the operation of the set. And we will see this operation of the set during when we apply or when we see the relational algebra and relational calculus, and also when we use some manipulation language during SQL. That's why we use it as, or we see it as a set of tuples and tuple a set of values. Okay, domain have 2 things. The logical definition, which is a set of values, and the format. For example, you can define a date, okay? Then a set of value will be date, but this date could have many formats. For example, year, month, day. Some use day, month, year. Some use the month before the day, then the year. Then you will define the format and the logical definition, the data type. Okay. When we use, if you remember, in ER diagram, we speak about entity, then we speak about entity type, then we speak about entity state. Same thing here. Relation, it's a abstract relation, okay? Just the relation name and relation attributes. When we speak about relation state, this means the instance or the copy or the snap shot of this relation. Then relation and the tuples inside it or data inside it. Then the relation state, it's a subset, okay. If we mention that relation state R for relation R small, for relation R capital, then it's a subset of the Cartesian product of the domain of its attribute. Cartesian product of the domain of the attribute. For example, attribute 1, Cartesian product with domain A2 for attribute 2 until you reach domain AN, or until what number of attributes you have. Then relation state, it's subset of all possible values for the attributes. We will give example next slide. Okay. Then domain for each attribute contains all possible values for this attribute. And the relation state will be subset for the Cartesian product for these domains of the attributes. For example, here, attribute customer name. Maybe we can define it as string and maximum length 25. Then all the combination of this character with maximum length 25 could be a value for this attribute. Then all this combination, it's part from the domain of the customer name. Here's a formal definition for we already speak about formal definition for the relation. Here's a formal definition for relation state. If we have relation state R for relation R capital, then it's a subset from the Cartesian product of the domain of all of its attributes. Okay. For example, if we have, let me show the example here. If we have this relation, which have two attributes, A1, A2. Okay, this is a relational schema, the relation schema. Then, if the domain of A1, it's just we make it like a hypothesis from us to see the example. If we have domain A1, 0 and 1, and domain for A2, all possible value for A2, A, B, and C, then the Cartesian product for the domain will be each value from the first domain with all values from the other domain. Then we will take each value from set 1 with all values from set 2. Then we have 0 with A, 0 with B, with C, and 1 with A, with B, with C. This all possible values for the Cartesian product. So if we define the relation state R capital, subset of domain A1 Cartesian product with A2, one possible subset could be we could take any numbers from here. Maybe these two values we have, but we cannot take value from outside this set. This is the meaning. Then one state could be that we have 0 and A, 0 and B, 1 and C, all subset from here. We could have another state. We could have, for example, 1A and 1C. Okay, also it's subset from the Cartesian product, the Cartesian product of the domains of all the attribute. Then the state, it's one possible state, or it's a possible state or population, or sometimes we called it instance of this relation. Okay. Then I think I already mentioned all this thing. Just we have here that we can see R relation state R for relation R as a set of tuples, and this tuple, it's a set or element of domain for each attribute A1, A2. Okay, each tuple will be all elements from the domain. It's another way to write it. Okay, I try to take this chapter very quick because we need to reach next chapter. This chapter have some terms at the beginning, not too much information. Okay. Tuples. When I speak about tuples, you have to imagine the relation like this, and the rows, it's the tuples. Okay. So tuples, this rows, not considered to be order. Okay, then it's not important to enter these tuples in order, okay, or use these tuples in this order. You can use this tuple here, or this row here, or down, up, anything. The order of the tuples here not important, or it's not considered to be order. But the attributes in the schema, when we write the relation schema, and when we write the tuples, it should be ordered, because we mean here in the schema, when you write a schema and you want to define the relation schema and you want to define the tuples like this. Tuples have value 1, value 2 until value n, and row have A1, A2, means attribute 1, attribute 2 until attribute n. Here it's better to give it in order. Why? Because I will understand that A1 as attribute have V1 in this tuple, have value 1, and value 2 for A2 until value n for A1. So tuples in the relation state like this, it's not supposed to be ordered. But when you define the relation like this and you define the tuple like this, it should be ordered. Why? Because when I make mapping here, if I want to look, I will understand that value 1 here for attribute 1. Another way to give you the freedom to order it or not order it, to write tuples like this. Tuples, then you give the name of the attribute and the value, the name of the attribute and the value. We call this self-describing tuple. Then you make the description or the attribute name and value directly inside the tuples. Okay, now we have some important characteristic. We need to understand this characteristic because this characteristic, and we can see later the concentrates. It's very important to get correct database and to get database to define the integrity of your database. About tuples, okay, values inside tuples considered to be atomic. This is very important for database integrity, that each value inside the tuple considered to be atomic. What's the meaning of atomic? Atomic means individual or single simple attribute value. This value that cannot be divided. I will give you examples here. You see this table or this relation have the name as full name, which have first name and last name. Okay. If you will use full name as atomic value inside your system, then it's okay. But sometimes in some systems, you need to use sometimes first name alone. So this value become non-atomic. Because, for example, for classes, computer science, it's considered atomic. Why? Because it's complete computer science. You cannot take science alone here and computer alone, because the meaning will be different. So if your system will use full name and do not want to know the first name separately, then it will consider atomic, normal, it's okay. But here in this case, if I need to use first name and family name separately, then this one become non-atomic, and it's better to divide it into two column or two attributes. Another example, when you have multi-valued attribute. For example, here I have a product number, and this product could have two colors. Then I cannot build in my database like this. This for relational model, not correct. I have to divide it into two parts. Here I can use the product ID with the color, so I separate this one in separated relation or table, and I take copy from copy. This will be taken separated. This one I will take copy from it as product ID. So what will remain here will remain the product ID with the price. Okay, then it will be divided into two relations. Why? Because I have this attribute with multi-value attribute. It could take multi-value. So it's not atomic, and now after separated, here it's all atomic and here all value atomic value. Then this is the meaning of atomic, that the values inside the table considered to be simple and single values that cannot be divided. This is the meaning of atomic. Indivisible values. Okay. Another characteristic that each value should be from the domain. So if we have table T and it's have values like this, so all these values should be from the domain of the appropriate or the referenced attribute. So each value vi from the table should be from the domain of the attribute AI. So it will be from the domain. Or we could, not always true, we could give null value. So it should be from the domain, or we could give null value if the restriction here allow us to give null value. For example, some values cannot be null. For example, names for employee, you cannot leave it null. However, it's not a key, but also you cannot give null value for it. So values considered to be atomic, values should be from or must be from the domain of the attributes, or it could be null value if null value allowable here. Okay, what's the meaning of null value? Null value, it's unknown value or not available value. About constraint or constraints, the meaning of constraints, that which value are allowable here or permissible here, which value we can give for the attributes here, or we could enter for we could use for the attributes or for the database, and which are not. Here we have 3 types of constraints. First type, inherent or implicit constraints. This come from the relational model. You as database engineer or application developer will not put or will not build this constraint. It's come from the data model. For example, relational model not allow a list a value for any attribute. You cannot give a list of values for the attribute, or any constraint come from relational model itself. Schema-based or explicit constraints, here you as database engineer or somebody that built the schema or bought the schema will put some constraint here. For example, cardinality ratio, okay, and participation ratio in the ER model. it's explicitly, you mention it explicitly, and it's come from the schema. That's why we called it schema-based or explicit constraints. Application-based or semantic constraints, you cannot put this type of constraints inside the ER model or relational database model, because you don't have the tools here to put these constraints, but these constraints can specify or enforce by the application developer. Okay, for example, if in some system you are not allowed to enter birthday or birth year to be less than 1950, then you cannot define this constraint inside your ER model or inside the relational, but the application developer can check it and not allow this type of data. Another example, the maximum number of hours that employee can work for projects, for all projects per week, 56, for example, or 60 or 70. Then this type of values constraints that cannot be defined in the ER model or relational model, it should be specified and enforced by application programs. That's why we called it application-based constraints. Okay. We have another constraints here, or we will give example, because we speak about schema-based here in this chapter. We speak especially about relational model and relational schema, and then we focus on explicit schema-based constraints. We have here for relational integrity constraints that we called it relational integrity, because we speak here about relational schema. So relational integrity constraints, it's explicit because or schema-based constraints. We have 4 types. The main 3 types that we can define in the schema: 4 types of relational integrity. 3 types come from the schema explicitly, and we can define it in the schema. Also, we can define the values or the domain with the schema. These 3 types: key constraints. We speak here especially about yes. You speak with us, or you? Okay. We have key constraints. It's about primary key constraints. We will speak about it. Entity integrity constraints. Actually, it's about foreign key and its relation with entity itself, integrity. And here, referential integrity constraints, it's about foreign key and its relation with the primary key. Also, another constraint, the domain. We mentioned domain many times. We will speak about each type of these constraints here. Okay, about key constraints. We will have here 3 terms: super key and key, or between brackets, I will name it later. I will take one and name it the primary key. So we have super key, we have keys. Keys, we have 2 types of keys. We have candidate key and primary key. Let's speak about each of this. What is a super key? Super key, it's a set of attributes that there is someone. Ahmed, do you have a question or?
No, Doctor. Sorry.
Okay, my friends, please focus on your mic. Open your mic only if you have a question. Where is it? Okay, here. Okay, then super key, it's a set of attributes that no 2 tuples have the same super key. So if you have, for example, relation. Okay, let me, instead of okay, if you have this relation and you have, for example, this attribute A1, A2, A3, A4, and you have some tuples. Okay, set of tuple attributes that always have diff for every tuple considered to be super. Then no tuples in the valid relation have same values for the super key. It's not repeatable, I mean, in 2 tuples. Okay, then if I have in tuple 1 super key, it should not be equal to tuple 1, tuple 2 super key. Okay, we have another term, key. Key, it's minimal super key, or when I take minimal attribute from the super key that it's uniquely identify each tuple. Because super key could have attributes more than the key itself. This means I can remove some attributes from the super key and it will still a super key. But when I reach minimal super key that I cannot remove any attribute and still a super key, this one we called it a key. Then a key is a minimal super key that if we remove any attribute from it, does not become a super key or become not a super key. So if we have a super key K, for example, if we remove any attribute from this super key, and it's that is I will describe it by example, it's better. If you have, for example, students, social security number, and name, and birth date, for example, you can take social security number with the name as super key. You can take also social security number, name, and birth date, all this as a super key. If you remove birth date from this super key, it's still a super key. If you remove name, it's still a super key. Okay, but you cannot remove, for example, student number here or social security number. Then the minimal super key, this one, we call it a key. Okay, then that's it. If I remove any value, it will not become a super key. It's a key. From this, I understand that each key is a super key, but not all the super key is a key, because this one cannot be key when I have the name, and because I still can remove name. Okay, when you cannot remove any more attributes, then it's the key. Okay, in this example, we have a relation schema for car, which have a state, register number, serial number, make, model, year. This relation schema have two keys, a state with register number and serial number. This register number, if you remove a state, it's not unique, because this register number inside this state, it could be repeated in another state or another region. Okay, that's why it's a key, because if I remove a state, it will not become unique, and if I remove register number, it will be unique, because state here, this car have many states. Okay, and if I have car number in this state, maybe another car with the same number in another state, because it's combined from the state and register number, or I could use as a key the serial number. So I understand from here that as a key, I could have more than one key. Each key considered a super key, but not every super key considered a key. For example, I could take serial number with make here, make with serial number, these two, I could take them as a super key, but I cannot consider this super key is a key because it's not minimal. When I remove this make, then serial number alone, it's a key because it's minimal now. Okay, about key constraints, we continue here. Each key, for example, here we have two keys. Each key we consider it as a candidate key. A candidate for what? A candidate for a primary key. So we have usually several candidate keys in the relation. One of this candidate key can be choosing as a primary key. Here, we mentioned that one is choosing arbitrarily to be primary key. And this primary key in the relation, we underlined it. And you have to focus. Primary key could be more than one attribute. It's not necessary to be one attribute. You could take two attributes. But the idea here, if you removed one attribute, the second one will not identify or uniquely identify this relation or this. So it could be 2 or 3 or 4, but it's minimal super key that can identify this tuple. Then the primary key is used to uniquely identify the tuple in the relation. And this key or primary key usually have one attribute, but sometimes could have more attribute. Defining a primary key very important to make the relationship between the relations or between the tables. Okay, then what if I have more than one candidate key or more than one key? Which one I should use? I said it's arbitrary, you can choose one, but it's better to choose the smallest size candidate key. For example, if you have two attributes, candidate key, and one attribute, candidate key, it's better to choose the key with one attribute, not the key with 2 or 3 attributes. Okay, it's better, not necessary, it's better, because sometimes you have restriction from, for example, from the environment itself or from the user. The user wants you to use this identifier as the key, not the other identifier. So now in this case, you have to use the suggested key. Okay, relational database schema. The term before that, relation schema. Okay, focus. Relation schema, we define it formally as R. Okay. Then attribute 1, attribute 2, until attribute n. Now we speak about relational database schema. We usually use S to define it. So a set with the name S of a relation schema, then in relational database, usually the relational database schema, usually you have more than one relation or more than one table, R1, R2, R3, and so on. So you can define it formally like this. Relational database schema. It's a set of relation schema, R1, R2 until Rn. Each one you will define it like this. R1, it's from attribute A1. Okay, so here relational database schema. Before that, we name it relation here. Relation schema, because schema come 2 times. This one, relation schema, we define it like this. Then relational database schema, it's a set of relation schema. Okay. And a set of integrity constraints. This integrity constraints, okay, including key constraints, which we already mentioned it, entity integrity constraints, which we will mention it now later, and referential integrity constraints. So you need to define the set of relation and the constraints for this relation. This diagram for the schema diagram. Here we define the relation employee and this attributes, relation department, this attributes, and here the way to define the key or the primary key. So like this, we defined the relation and the constraints which we use here, the key constraints. Still, we have 2 types of constraints that we have to show it here. We will return to this one and know how to draw it or to get this schema in chapter 9, inshallah. Okay, similar to relation state, relational database state, or DB, it's a set of relation state. If you have relation state R1 for relation R1 capital, we define it as a subset of domain Cartesian product of domain of its attribute. Yes, so each set here or each relation inside the database, we make a set of this relation state to define the database. Here a relation, and here the attributes and the relation between these attributes all with each other. This is the schema diagram. This way it's a relational database state, okay, and this we can describe it as tables like this with the data, because we speak about the values of the tables and the relation between these tables, okay, sometimes called snapshot or instance of the database, the copy that you have now currently in the database. Let me check how many slides we still have. Oh, bah, too many slides. Okay, I tried to make it faster because also I have another lecture at 1 p.m. Sorry, I will not give break. Is it okay for you?
Okay, Doctor. No
Okay, Doctor, no problem.
Okay, Doctor, no problem.
Okay, then the relational database, it's a union of all relational state. We have relational state, union of all relational state, it's the relational database state. This show you relational database state for the company. You can see this relational state and relational state and set of all this relational state or union of all this relational set considers a populated database state or relational database state. Okay, about entity integrity. The primary key attribute of each relation cannot be null value. It's important. Even any DBMS, when you try to enter a null value for primary key attribute, it's not allowable. Okay, that's why when you build your database, you have to define this type of entity integrity. You have to define the primary key. You have to define the candidate key that cannot be null. If you did not define it, cannot be null or cannot take null value, then the user can give null value here. If you did not define this key as a primary key, then the user can give null value, and this cause problem with the integrity of your database. So primary key values cannot be null for any tuple. That's why we define it like this. If we have tuple and we have the primary key cannot be null for any tuple in the relation state. R small, R capital like this, it's relational relation state. Okay. If the primary key also have more than one attribute, if you have, for example, a primary key that have two attributes, like in the example of the car, we have the state and number, I think. This example for the car, we have register number and the state. Okay. It's primary keys that have two attributes. Cannot be null. Any of these two attributes also cannot be null. Not the whole primary key or the whole primary key, or if it's more than attribute, any part from this primary key cannot be null. It's disallowable to take null value. Okay, this then we speak about key constraint, entity integrity constraint. It's about primary key cannot be null. Referential integrity. It's come from reference. Okay, referential integrity. These constraints include or involve two tables, and the relationship between these two tables. If you have relationship between two relations or two tables, then you use referential integrity constraints between these two tables, as you have referencing relation that reference to other relation. How to do this? We choose or we take the primary key from copy from primary key from reference relation to referencing relation. So usually foreign key point to primary key. Point to is its origin. Then referencing relation have the primary key, the foreign key which is a copy from primary key of the reference relation. Let me show you here. For example, in this schema, we have here for this table, department and department location. We have department number. This department number, primary key. And we have also here department number inside department location. It's foreign key here. So this referencing relation and this referenced relation. Referencing relation pointed to reference relation. So foreign key pointed to its origin, the primary key. So if we need to make a relationship between two relations or two tables, we take a copy from the primary key, okay, from the parent or from the referenced relation to referencing relation as a foreign key. That's why it's called a foreign key. It's come from another relation. That's why it's called a foreign key. Like me here, a foreigner, because I'm not originally from Turkey. I come from another country, then I'm a foreigner. That's why in the referencing relation, we have a foreign key that reference to a primary key from the reference relation. We can define it like this. If we have tuple 1, for example, in R1, that is reference to tuple 2 in R2, then the foreign key in T1 should be or should equal the primary key in T2. This is the referential integrity, that every foreign key should have or should reference to a primary key. You cannot have value for the foreign key that do not have original value from the primary key. To display this referential integrity constraint, we use arc to point from the foreign key to the primary key. I should write this one here. Okay. Okay, referential integrity constraint. I already mentioned this, that we have in referential integrity constraint the value of the foreign key either it's same as the value of existing primary key in the reference relation or none. Sometimes it's not necessary to enter the value for the foreign key. For example, if you have two relations, okay, and in this relation you have foreign key here, it could be null. It's not pointed to any primary key for this tuple. It could be null. It's depend on if it's allowable to be null or not. This schema, we will return to it. Okay, but I will show you here. Here we define the schema, we define the key constraint, and using this pointers or this connectors, we define the referential integrity constraints. Okay, we have some other or some operations that could be done on the relation, and in this operation you need to look to the constraints when you make this operation. For example, when you insert a new tuples, a new row in the database, you could violated some constraints. So as a database engineer, or when you design your database, you should take this integrity constraints violation into consideration, and you have to define the operation in this type of violation. If any violation for insertion or deletion or update of the database, you have to define what operation you will do. Usually, or in some cases, we make like cascaded or propagate updates when you update. This means one update could make another update in the database depending on constraint that you define in the database. I will give you here example. We will take the insert of tuples possibilities, the delete, and the modify or update. If any integrity violation happen, we could take some action, maybe from you, maybe from the DBMS itself, database management system itself. This operation, if make any violation, it could be restricted or rejected, or it could be performed, the operation, but tell the user that operation make a problem. I think it's difficult to apply this one, because here you will have integrity problem with this. Okay, most user will not read the system messages and maybe just press OK or next or do it anyway or something like this. Okay, that's why we usually use restrict or cascade option or set null option. Usually we have three types of operation here that I can define it during defining my database schema to identify what action should be taken if integrity violation happened. Restrict, this means not allow this type of operation. Cascade option means, for example, if you update something and it will cause integrity problem, then make another update. For example, if you update the primary key, update all other values inside the foreign key to keep the integrity. We will take example here. Or set null option. For example, if I delete value from database that have, or row or table that have primary key value, I go and look for all tables that have foreign key. This foreign key will not point it to anything than this violation for integrity here, for referential integrity. So I could set null or make cascaded. This means it will be deleted, all these rows that connected to this primary key. Then I can set null if it's allowable, or cascaded. This means all will be deleted, all the related values. So another thing, execute a user specified error correction routine that user define error correction if any violation happened. Okay. If I insert inside the database, okay, any values, and these values violated some constraints, it will not be accepted from DBMS. For example, I could violate domain constraints if I try to give values for attribute that it's not from the domain. It's not allowable actually, or accepted from DBMS. For example, if you want DBMS, if you want to enter name instead of birth date, all DBMS will not allow this, because this will violate the domain constraints. For the key constraints, okay, also if you try to make the key, for example, give null value for the key attribute, here you will have problem with the key constraint and entity integrity constraint, and this not allowable also. It's not, it will not be accepted. Okay. For the key constraint, if you try to enter values that already exist in another tables, also it will not accept the referential integrity constraints. When you try to insert values for the attributes, and the foreign key, the value of the foreign key not exist in any primary key, it will not be also accepted. Okay, then I think this type of insert violation will not be accepted from DBMS, but you need to focus that you have to define the referential integrity correctly, and the entity integrity correctly, and the domain correctly. Then DBMS will help you here to keep your data integrity. Okay, will not allow any violated in the insert operation. Here in delete only violate the referential integrity, because if you want to delete any row and it's have a primary key, if any foreign key connected to this primary key, you will have problem here with the referential integrity. So what should happen here? If the primary key value being deleted have reference value in the foreign key value. You can make it restrict or cascaded or set null. If you make the option restrict, this means you will reject the delete operation. Then the system will tell the user you cannot delete this row because primary key or foreign key, there exists a foreign key. Okay. If cascaded, this means if you delete a primary key or a row inside this table, you will go to the referencing table and delete all the tables that have foreign key reference to this primary key. This is a cascaded. Then, for example, you delete the employee and make it cascaded, then all the dependent for this employee will be deleted automatically. Set null, this means if you delete the primary key, any related foreign key will set to null value if this choice only if null value is allowable for this foreign key. It's depend on what type of data could be given this foreign key. It's allowable to be null or not. Okay, then usually when you make the database design and you create your database, you have to define one of these three options. And you have to be focused about, especially about cascaded here, because cascaded maybe cause problem to and delete many tables or many rows from the database. For example, if you wrongly make it cascaded for you have, for example, employees table and the project, and one of the employee manage a project, okay, and you have foreign key for this employee inside this project, and you make the deleted here cascaded. This means delete the employee will delete the project. Oh, it's causing a problem for you. So you should know when to use cascade, when to use restrict. Use cascade usually if the exist of this value totally depend on the primary key, totally depend on this table. If you delete this, for example, employee, you don't need the dependent, but if you delete the employee from your database, you still need the projects, then you cannot make it cascaded here. For update, actually, update is similar to delete followed by insert. Okay, so you need to specify similar option as delete, because it could violate if you update here. I speak about if you update the primary key. If you update the foreign key, it could violate the referential integrity. Okay, but if you update any ordinary attribute, not a primary key or a foreign key, it could violate only the domain constraints. So if it's violates the domain constraints here, it will be rejected from the DBMS itself. If it's violated the referential integrity, also it will be rejected. But if the update violated the primary key or the key constraint, here you need to define, you need it cascaded or you need it rejected. If rejected, then or restricted, then it's mean you reject this update operation. If you make it cascaded, then this mean if you change the primary key, any copy of it, any foreign key that pointed to it will be changed. Not deleted, will be changed here. Okay. Here you can solve this exercise. Try to solve this exercise at your home. Okay, we will start with